Hello and welcome to this week's edition of Developer Skill Sprints. My name is Brian Alexakis and I'm a Product Marketing Manager here at Embarcadero Technologies. Today's skill sprint is all about promoting healthy apps by separating app logic from the UI using common patterns. You can follow my releases by catching me on Twitter at IoTBrian. Skill sprints are quick, to the point, and feature a working demo to illustrate the presented concepts. There's a lot to cover today, so let's jump right in. If you break up the logic inside an application, you can separate code into three different distinct categories: presentation logic, domain logic, and data access logic. Presentation logic is what your form is doing and what controls are presented to the user at any particular time. Domain logic addresses the problem domain you are trying to solve. Data access logic defines how the application talks to the DBs and saving and loading of information. Abstractly speaking, this is the separation of the UI, middle layer that handles processing data, and the backend that knows how to talk to a particular data source. Where you put all of this logic into your application and how you separate this logic within an application really matters a lot. A lot of effort over the years has gone into how to develop design patterns to deal with this situation. Before we dive into the concepts of a model view model, let's first analyze the pros and cons of not using an architectural pattern. The RAD approach makes it easy to combine presentation logic, domain logic, and data access logic in, say, a UI event handler. There are pros and cons to mixing application logic together within a single code block. The whole point of RAD is to, of course, build things quickly. That speed of development can backfire on larger scale programs unless you are very, very careful. It's easy to understand as it is a sort of typical approach to developing applications. However, as the application grows in complexity, it becomes harder to maintain and more brittle. Changing some aspect of the presentation logic will impact changes on the domain logic, for example. This approach is also hard to test because the domain logic is mixed in with presentation logic, and that makes it hard to run unit tests, as it becomes difficult to isolate application logic. Further, the mixing makes it difficult to update or completely replace a UI with a new one. For example, migrating to a mobile UI, you might need to do a complete recode in order to remix these concepts. There are a number of architectural patterns that have emerged as popular ways to divide a given software application into the three areas discussed earlier. MVC stands for Model View Controller. The central component of MVC, the model, captures the behavior of the application in terms of its problem domain, independently of the user interface. This model directly manages the data logic and rules of the application. A view represents the UI and the form components. Lastly, the controller accepts input and converts it to commands for the model or view. MVVM stands for Model View Model and is an extension of MVC. It was developed to simplify event-driven programming of user interfaces. All right, let's break down how the MVVM is architected. The most important distinction of MVVM is the focus on presentation layer. MVVM has nothing to say about the data access layer and very little to say about the domain layer. It is very much focused on the presentation layer. In this chart here, the blue arrows indicate who knows about what. Views know about view models know about the domain model, and views and view models know about each other. Another signature of MVVM is the use of technologies like live bindings to tie in the view to the view models in a visual way. The domain model is the model of your problem domain, and it is non-visual. If you architect it correctly, it becomes pretty easy to unit test the domain model. Some examples of domain models within an application might be iTunes. You have your artists, songs, plays, and ratings. Accounting applications may pull in data for accounts, transactions, and so forth. And with something like Salesforce, you might be looking at data for customers, activities, forecasts, and opportunities. View model is the representation of the UI. It is a non-visual model of all the logic represented by a form and all the data in a form. The UI rules, workflows, and processes that a user might interact with in that form are all modeled inside the view models. Because it is non-visual, it does not know about the UI components themselves, like buttons or memos, but it does know about the state and processes for the UI. And because it is non-visual, it can be unit tested. Views are the visual rendering of a view model. This is where the buttons, memos, and other UI components are defined. Live bindings are used to bind state and data between the views and the view model. This enables a minimum amount of code to implement. Since this is a visual representation, it can be hard to unit test, so it's a good idea to keep the implementation of the view as small and simple as possible. Let's jump into a simply implemented demo called Menial Tasks. This application was originally presented by Malcolm Groves, and you can find the source code for this presentation on the URL to the blog notes, which you can see on the screen. It is implemented in Object Pascal. This demo is a bare minimum of features to demonstrate the implementation of MVVM. It's a simple task management application, and there is a list of tasks on the left side of the application and a view to bring up the details of that task on the right side. We also have a series of buttons to navigate through the task list, and a couple of buttons to create tasks and to edit existing tasks. Let's go ahead and create a new task and give it a name and title with some details. So I'll give myself a name here, and these are the details. Okay, there we go. Let's go ahead and create another one. John Doe, is this guy even real? Great, so now that we have a couple of entries, we can click on one of them, and as you can see, the view is being updated with the relative information. And if we click Edit here, we'll bring up the details where we can make a change. If I hit Save, it'll commit the change, and if I cancel, it will retain the current value. So as you see here. Great, so this is very simple, but gives us a few key things to explore how it is MVVM can be implemented. Okay, so enough about the application itself. Let's go ahead and dive into some source code here and take a look at the structure for the project manager. First of all, I would like to point out that this demo has implemented unit testing, but we are not going to be going into unit testing as part of today's skill sprint. If you'd like to get more information on how the unit testing would work for this demo, please do reference my blog notes, and there you will find a link to the full presentation by Malcolm Groves, in which he does go into the detail of unit testing. So let's take a look at the structure of the project manager here. So you can see here that each folder represents the particular part of the MVVM implementation. Again, the model and view models are the non-visual representation, and the view is the representation of the UI. Let's take a close look at the model directory, and we'll begin with the task list file. Here we have defined a class called model.taskList. Has a few properties like count and an object list for tasks. The class exposes some functionality to add a new task, to test whether or not it contains a task. pretty straightforward. Let's take a look at the view model. Here you can see two classes, main and task. Let's begin by looking at task. The view model has a main view model which maps to the view, which can also be considered as the main form. A task view model maps to the child form, which is the pop-up window that you saw earlier that allows the end user to edit an existing class or task. Again, here it's important to point out that the view model task is not visual. So there are some properties which represent a task. So part of the model is exposed here. The view model main is also a non-visual class. Let's go ahead and open that up. It has a reference to a task list from the model. And again, the view model is responsible for exposing relevant data to the view. So let's go ahead and see how this connects to the view next. There are two classes defined under view, main and task. This represents the possible UI views. So if we go ahead and open up main, we can go to the design tab, and here you can see the UI components are laid out. To further reinforce the concept of views being a visual representation, we can look at the use cases for each class, and here you can see all kinds of FMX classes being pulled in for controls and forms and so forth. If we open up the view model, we can see that the only classes that are being pulled in are relative to our implementation of this MVVM solution, and it does not have any UI elements within it. And if we take a look at the model itself, either the task or the task list, you can see here that there are no there's nothing being pulled in from the UI, but only the relevant classes. We're going to take a quick look at how live bindings fit into this MVVM solution. Here I've opened up the design view of the task edit window that pops up when you click the edit button on an existing task. And there are three components that are allowing us to bind live data. We've got a action list, a binding list, and a task bind source. If we click on the bind source, we can examine the fields here that are associated with it. So we have three field definitions: a title, which is a string, a due date called due, which is just a fdate time, and the details, which is another string. And if we look down at the live bindings designer, we can see that the task bind source and those three fields are mapped to actual UI components: the edit field, the calendar selector, and the memo. Let's take a look at some slides to help illuminate what is going on with this MVVM solution. There are three actors involved in this example. Consider the Save button, which is part of the child view form that pops up after you click Edit on an existing task. In that child view, there is an action list, and one of the actions is the Save action. Typically, action lists have an onExecute and an onUpdate event. So in the case of the onExecute event, the save method of the view model is called. So what happens then on the onUpdate event of the task defines how the logic will be manipulating the state of the UI. In other words, the Save button will be either set to the property of enabled or disabled. The Save property of the view model, which in this case then talks to the task as part of the model, which then queries whether or not the information is valid. The view then decides what to do with this information. If it is not valid, the button is disabled, and if it is true, then the button is enabled. So this helps to show that the view model is making a value judgment about whether or not the data is valid within the context of the view model. It does not have anything to do with the actual UI representation itself. The view takes the information from the view model and decides how to represent that in the UI. So in this case, again, it means whether the button is enabled or disabled, depending upon what the view model validates against the data. At startup, View provides the view model an anonymous method to call when a child view is needed. Sometime later, the Add Task button is clicked and the view model add new task method is invoked. The view model then creates the child view model and calls that anonymous method, passing the created view model in as a parameter. The anonymous method then creates the child view and passes it the child view model, and then is responsible for actually representing it and displaying it within the application. When the child view closes, the anonymous method cleans up, refreshes bindings, and so forth. The onEdit task returns back to the main view model, and when the anonymous method returns, the view model still has access to the child view model, and so it can access data if required. So that concludes our very brief overview of MVVM. Before I get to the final slide, I would like to point out that next week we will be featuring a skill sprint on building an application with the multi-device designer, consuming JSON from SharePoint.com and their REST API. That's going to be, of course, next Tuesday, the 24th of February, 2015. Well, this concludes today's skill sprint. The blog notes are currently live at the address shown on the screen, embt.co/blog-mvvm. There you will find Malcolm Grove's Code Rage video presentation on MVVM. It really goes into a lot of the detail that was obscured in today's presentation, and I would highly recommend that anybody who is interested in further pursuing being able to implement MVVM in your own applications to take a look at that presentation. I also have on the blog notes some other links that will should be of interest to you in regards to MVVM. I hope you have enjoyed today's skill sprint, and I will now turn it over to Q&A.
So first of all, I'd like to just mention that I'm going to be creating a follow-up blog post with an implementation for this demo in C++ and create some additional information in that blog post to help make this presentation a little bit more clear. Let me go ahead and take a look at some of the questions here. First of all, we have one from Alf.
He's saying that with a more complex, basically saying with a more complex application, you're going to have lots and lots of files, and that's true. One thing, the RAD approach, where you combine all your data access and model manipulation and UI all in the same form, simplifies development in that you have one form that contains everything. But as far as maintainability goes, it becomes a little more complicated. And then with the additional side effect, one thing about MVVM is, let's say later on you want to make a mobile version of your application, or I don't know, deploy it over the web or something like that, where you're going to change the view in the future, radically change the view in the future. MVVM makes that trivial because none of the business logic or data access is tied to the view. And so you can slap a new view on it without changing things. The other place that becomes a big deal is, let's say you're currently using grid component X, and in the future you need to switch to grid control Y for whatever reason. Now, if you've ever maintained an application, you know that happens way more often than you'd like to think it does. And by not having the UI, not having the view tied to the data access, you're able to quickly swap out the view by changing out those grid controls without having to change all the data access in the model view. Now, as far as how to organize it, if you looked into the example Brian showed, how it showed everything split into separate folders, that is a really common organization pattern that you'll see where you say these are the views, these are the models, these are the view models, and it splits it up that way. So that's a good way to do it. And then you'll usually see naming where things that are attached share common names. You might have, like model, let's say model foo, view model foo. So everything that has the foo in the name matches together. Now the problem that comes into place is that you don't always have to have a one-to-one across those three categories. So you might have things that share, or one view that shares the same view model behind the scenes. So then you have to have conceptual names.
Let's see here. We have a question from Dan regarding using live bindings. Are there any tricks for that when you start to move view components and logic to separate units?
It still works. It'll actually show up in kind of a goldenrod color to show that you're from a separate unit. So if you have your data access controls in a separate unit, as long as your view is using that unit or your view model, then you just can use live bindings and it can access them from a separate unit. So one thing about MVVM is it's kind of MVVM is one pattern, and it's a good pattern for separating your data access and your view model from your view, a way of separating things out. You have your data access, your business logic, and your view separated. So I'm trying to think, if you're doing actual MVVM, you're probably not going to be using live bindings anymore. Let me think. Can you do... Yeah, I don't think you can do live bindings, because in order to use live bindings with MVVM, your view model would have to define the live bindings, I believe, because your view does not have any concept of your data access. Is that right, Brian?
Well, the live bindings, as far as I understand it, are used to basically connect the view to the view model.
Oh, yeah, that's right. Okay, yeah. So as long as your view model exposes
Right.
that's right. I was thinking in the direction. So if your view model exposes the bindable data sources, then you could then have your view using the view model and then do live binding. You can live bind to a data source in another unit. So you'd be live binding to the view model, not to the data source.
That's correct, yeah.
Right.
I kind of like to think of it in terms of, if you want to make the analogy of a web paradigm, it's sort of like a middle layer or something.
Exactly.
Yeah. Okay. Let's see here. Had some positive feedback from Chris. Great session. It's great to have sessions on technique rather than just technical feature demos. It would be good to see more of these. Okay, we will definitely think about doing more of these kinds of skill sprints. Let's see here. Are there any graphical tools available that show all the interactions between all the forms? Do you know? I'm not sure.
I'm trying to think. I can't think of anything that does that.
Yeah, I don't know off the top of my head. I'll certainly ask around and see if anybody has any opinion on that. I'll have to get back to you on that one. Are there any project types in Delphi for this? I believe you probably are meaning if there are any sort of prepackaged or example project types?
He says yes.
Yeah. I don't know. Do you know if there's any obviously other than downloading it from Malcolm, I don't know if there's any packaged.
There isn't like, you can't go like file new
Right.
MVVM project, but you can create your own project templates that you could use. So you could add one that was an MVVM that had your model view model in there. The thing that creating a new MVVM application is not overly complicated as far as doing that, but then you're going to have you're going to be using basically your views will be your form files with the unit behind them. Then you'll have probably data modules in the other ones, or just unit files in the other ones. So you just conceptually in your head how to do that. So if you were to create a new project, a regular project now, all you need to do is create a new folder called view and move your unit file into that folder there, and then create folders for the other ones. So no, there isn't a project type already for that. That'd be an interesting thing to create and make that available, that people could say, here's an empty MVVM application to get you started with.
Alf is pointing out, or rather asking about, that it may be under Model View and right-click. So I'm not really sure, but worth looking into.
Yeah, that's true. There is a model view that you can use. It'll show some things, but not, excuse me, not give you all the interactions at once, I don't think. But yeah, the model view is actually really useful. I use that sometimes.
Okay, great. So also Troy pointed out that refactoring code makes your code more readable, and why not just refactor to clean your code? Well, yeah, I mean, sure.
Well, you can refactor a RAD app to an MVVM app.
Right.
It's a lot of work, but you can do that. And I know people that I've had come into legacy applications that are still being maintained. They're like, we got this application, we've been trying to maintain it for a while, and it's just getting harder and harder to maintain. And so they'll do that. They'll refactor it to MVVM, or refactor to interfaces. If you talk to Nick Hodges, that's one of the things he's working on, is taking an existing code base and putting interfaces in there to make it testable and easier to maintain.
Okay, Andrew has a tip here. I have found that careful use of folders and a good file naming convention solves a lot of the problems with many files. My experience is that maintenance is a whole lot easier with MVVM than with huge RAD style files. Yeah, that's exactly the sentiment that we were mentioning earlier. So thank you for that. Let's see here. Are there any MVVM frameworks for Delphi? Oh, I think we just spoke about that. I'm not sure. I see what live bindings and T-string grid will become faster and feature comparable like DB grid. I'm not sure about that question. You see that one, Jim?
Yeah. Yeah, I'm not sure what you're asking there, Daniel.
Okie dokie. Well, that's the end of the questions so far. And again, I am going to be creating a follow-up blog post with a C++ implementation, possibly this week, but most likely next week. And also next Tuesday, I will be doing another skill sprint on REST API on SharePoint.
If you do a Google search on Delphi MVVM, there's actually quite a few pages out there that talk about this and have different examples and stuff like that. So you can do a lot of reading and find out some more information just by Googling around the web and looking at things. So that's recommended as well.
Well, Jim, I really appreciate you coming out, even though you've got a cold. It was very helpful having you here today.
Sure, my pleasure.
Okay, follow-up comment from, let's see, live bindings are quite slow compared to the TDB grid and all of the old DB-aware components.
Yeah, live bindings is a different way of approaching data binding. You can do, if you want the fastest data binding, you can do it all in code. It's just different approaches. So in some situations where some situations live bindings make sense, some situations DB-aware controls make sense, some situations in code saying, hey, put this data here and this data here makes sense. I've had projects that I've used all three types, and in some places it makes sense, some places something else makes sense. So you just need to be cognizant of the requirements of your project and what makes sense. In a lot of places, live bindings make perfect sense, but not every situation. That's one of the things I love about Delphi, honestly, is that it doesn't tie you to one way of doing things. And so as other, if in a certain situation, if you need to do it a different way, that's fine, do it a different way. So yeah, just because of the nature of the way live bindings works, it's a little bit slower than some of the other data binding techniques. So use whatever makes sense for your project.
Okay, I'll leave the chat open for a few more moments if anybody has any more lingering questions.
So Daniel's saying that it breaks the separation from concern using DB-aware components. So let's see. I'm trying to think who did it. Somebody else had a video. I think it was MVC instead of MVVM, which is model, view, and controller. And the idea, they did use it all in code. So so you don't have to use live bindings or data-aware controls in MVVM or model view controller. You can have the model view put the data into or make the data available, and then the model would then take that data and put it into controls. So you'd write code that would do that instead. So you don't have to use data-aware controls. You don't have to use live bindings. And if you were, I guess you could probably get away with data-aware controls if instead of having, because the data-aware controls aren't bound to the data source, they're bound to the view model. So there's a few different ways of tackling that.
Okay, we got one quick question here from Alf. If using globals in a separate file in order to be used more than one form, is making that class a better approach than singulars?
Generally speaking, yes. You should really, I mean, the general guidelines are that you don't want to have global variables. The reality is that frequently in applications you do have something that needs to be available globally. If you do have that situation, then it's generally better to have that in a class, because then you can have that class is interacted in a certain way because with a class you can control how that data is interacted with, where if it's just a global variable, like an integer or something like that, if you have two, for example, let's say you have two integers that are used together, you don't have a way to prevent one from being modified without the other being modified unless you go through a class. So with the class, you could make those interactions atomic, for example. So instead of exposing it as a property, you can expose it as a procedure. So you have to set both integers at the same time via procedure, for example, or things like that. So if you're going to have global variables, which end up being actually happening frequently, unfortunately, then yes, you should have those in a class. And then other techniques you can do, for example, you could have a factory that produces that class for you that uses behind the scenes singletons, for example, or something like that.
Right. Yes. Oh, since we are definitely on the topic of design patterns, I was just curious if he means by singulars the singleton design pattern.
Unless he clarifies, I guess my impression was that he meant
more or less, yes. That's kind of what I thought you meant. So, okay. Okay. Is there a example using DataSnap to get the data remotely? So, in other words, I guess you're saying using DataSnap in the data layer. I'm sure there must be quite a lot of resources out there, don't you think, Jim?
I'm not sure if there's a sample, an MVVM sample that does that, but the concepts are the same. You just change your model to pull the data from DataSnap.
Well, in terms of MVVM, like I was saying in one of the slides, it really has nothing to say about the actual data layer.
Exactly.
So, any DataSnap solution that you can plug into the data layer, is a valid solution in regards to an MVVM application. Great. Well, I'll leave the chat room open here for a few more minutes. Okay, here we have a question from Richard. A database application example would be interesting, where data modules might be used for the view model, and use of adapter classes to represent more complex database structures. A little more of a comment than a question, I suppose.
Yeah, the trick always with these is to come up with a sample that shows the parts, but that is not so overly complicated that you miss the important bits because everything else is there.
We have a quick question from Carl regarding if MVVM, does it take much extra planning when starting a project? Yes, certainly. One of the things that I think is important about the concepts of MVVM and other design patterns that deal with UI is to well understand what your UI is going to be doing. And it makes, if you properly implement it, it makes it really easy to then make changes to that UI. But yes, I think it does require more planning than otherwise. The typical RAD approach without an MVVM type solution, like I was pointing out in one of the slides, is it's quick to do, it's great, but if you're building something bigger, you're going to want to plan for it, regardless of your approach. Okay, so another question from Walter. If I understand correctly, the view model will be at the client side. No, the view model actually supplies information to Vue. So the view model takes keeps track of state and data, and then the Vue will query the view model for that information. So in a way, roughly speaking, it's kind of like a middle layer, if you will. What's the real difference between MVC and MVVM? Well, MVVM is an extension of MVC that is really focused on the UI, and one of the biggest differentiators is its use of technology like live bindings to streamline the connection between the view and the view model. Okay, let's see here. It looks like we have Dan's having some issues getting the demo working. Dan, which version of RAD Studio are you running that in? Quick follow-up question. Should the data XE7 update 1? Okay, I'll be sure to take a look at that and see if I can replicate that problem. And again, I'm also going to create a C++ implementation for XE7 as well. But yeah, I'm not sure about that issue. I'll be sure to take a look at it. And if there is a problem, maybe we need to re-upload a different version. Not quite sure. Okay, follow-up question.
Well, if he's getting an error on the DCU, he needs to do a rebuild. Well, I'd suggest doing a rebuild based on that error message.
Okay, follow-up question. Should the data layer be able to access the controls on the view model or use properties, etc.? No, let's see. The data layer shouldn't. Oh, well, if you mean by controls, if you mean like UI control, no.
Right. Yeah.
The idea separated.
Yeah, the data layer doesn't have any awareness of the UI or
right.
the model.
Right.
Or of the view. Sorry.
In a multi-tier application, what layers go on what machines? From Roger Dunn. That's a great question. Jim, do you have any feedback for that one?
So you can use, let me think. So you can, obviously the view goes on the client, but if you're building a web app, your view would be, I guess, in the web browser, which is technically the client. The view model would be on the client, I believe. Yeah, the view model would be on the client, depending, well, I guess you could move it around anywhere you wanted to, technically. I think the best idea would be to put the view model on the client because its purpose is to maintain state.
Yeah, it's kind of a trickier question because when you introduce multi-tier applications, it really, you have a lot more approaches to take. Yeah, that's a really good question, actually. It's not an easy one to quickly answer, that's for sure.
You could put, I think the view model and the view would be on the client, but then the model could be either on the server or on the client.
Dustin has a quick question here about any other resources for MVVM for Delphi. I know that same question came up in our earlier broadcast this morning, and you had mentioned that you can just, if you Google it, there's a lot of great resources that'll pop right up.
Yeah, there was I did a Google for Delphi MVVM, and I saw a few different resources that came up.
I'll leave the questions open for a few more moments.
So it sounds like maybe you visit this with the data snap multi-tier example.
Yeah, that's something that I think we should definitely look at.
You know, like so I've had lots of discussions with people about MVVM and MVC and XYZ, whatever the model is, and my opinion is that it's important to learn about these models and the concepts of these models and what the principles are that they convey. And so the idea is that you want to separate things apart so that you're able to easier maintain the different portions of the application so that things aren't tightly coupled together, right? So it's like using interfaces in your code. Same sort of concept, right? By separating the implementation from the interface, you're able to easier test parts of your code. Now, a lot of times people are like, well, I want a strict, hard, fast rule about this or this or this. Nick Hodges and myself got in a huge argument about whether or not you should ever use nil in your code. And he was saying, no, never. And I said, well, maybe there's some corner cases, but the reality is, generally speaking, yeah, you probably shouldn't have nil references that you're passing to parameters and stuff like that. Now, so my point is that there may not be a hard, fast rule in every case, do this. But I think that if we take what we learn from MVVM and MVC and all these different design paradigms, it does two things. One, it helps us put more thought into how we architect our applications to make them more maintainable, even if we don't maintain a strict MVVM implementation. And two, it gives us a vocabulary that we can use to talk to other developers on our team, etc., about how we're implementing things. And so even if you're not strict, I'm doing air quotes here with this, strict MVVM, I think we can still learn a lot in how we can be better architects of our applications by the principles covered in here.
That was a great comment, Jim, and that actually touches on the next question from Carl regarding implementing MVVM within a team where different members of the team may be working on different parts. I really think that kind of comes down to a application development management problem more than something that's specific to MVVM.
But yeah, you do have that possibility. You could have members working on different parts.
Yeah.
I've actually been in teams where we were working that way, where you had some team members worked on the model, and other team members worked on the view, and someone else maybe worked on the middle. What I found, generally speaking, is the best teams, everybody has parts that they're most familiar with, that they work with the most, but they do move between the different layers and different parts, either through pair programming or some other technique where you're aware of the entire whole, but you have maybe a spot that you're focused on.